Right now, while most of the country is still thinking about back-to-school schedules and the last few weeks of summer, something enormous is quietly locking into place over the Pacific Ocean, and almost nobody outside of a small circle of meteorologists has fully registered what it's about to do to the next several months. It isn't a single storm, it isn't a single heat wave, it's the entire backbone of the planet's weather system shifting into a configuration strong enough that the scientists tracking it are running out of their own vocabulary to describe it. And the most unsettling part isn't the shift itself. It's how few people are actually paying attention to it before it arrives. Picture two weather maps side by side for a second, because it helps make the abstract feel concrete. One map is what most people are quietly assuming the next several months will look like. A fairly ordinary transition from summer into fall, then fall into a fairly ordinary winter. The kind that shows up in a typical almanac without much fanfare. The other map is what a growing stack of independent, credible forecasting agencies are actually projecting right now, built from real ocean temperature data, not guesswork. A map with an unusually active, unusually amplified pattern stretching across an entire hemisphere, reshaping rainfall, drought, and storm activity on 3 or 4 continents simultaneously. Only one of those two maps is actually supported by the data. And right now, most people are still mentally living in the wrong one. Here's the plain, documented reality behind that. As of the most recent update from NOAA's Climate Prediction Center, El Niño conditions have officially strengthened to the point where forecasters are now placing the odds at greater than 90%. That this event becomes what's classified as a very strong El Niño by the time fall shifts into winter. Not possible, not one scenario among several. Greater than 90%. That's about as close to a consensus forecast as climate science ever produces this far in advance. And it's the kind of number that should genuinely reframe how people think about the coming months, whether or not they've been following the story up to this point. To understand why that number matters so much, you have to understand what El Niño actually is, and why this particular one has scientists using language they don't reach for casually. El Niño is the warm phase of a naturally recurring climate pattern called the El Niño Southern Oscillation, or ENSO, driven by unusually warm water spreading across the central and eastern tropical Pacific Ocean. It's not a new phenomenon. It cycles through roughly every 2 to 7 years, and forecasters have been tracking it for decades, using a specific patch of ocean called the Niño 3.4 region. What's different this year isn't that El Niño showed up. It's how fast it's growing and how far current models expect it to go before it's done. The latest ensemble forecast data from the International Research Institute for Climate and Society, pooling results from dozens of independent forecasting models run by agencies around the world, shows 25 out of 26 of those models placing this event in the very strong category, meaning sea surface temperature anomalies of 2 degrees Celsius or higher, sometime between October and December of this year. And within that group, 15 separate models are now forecasting anomalies reaching or exceeding 3 full degrees Celsius, a number so far beyond the standard classification scale that the researchers publishing the forecast specifically noted it sits well beyond their highest defined intensity category. Read that again slowly, because it's worth sitting with. The tool scientists use to measure how strong an El Niño event is wasn't originally built with a category high enough to describe what more than half of the world's best forecasting models are currently projecting for this fall. For context on just how rare that territory actually is, only 3 previous El Niño events in the entire modern historical record have ever qualified as genuine super El Niño events, crossing that 2-degree threshold with real staying power. 1982 into 1983, 1997 into 1998, and 2015 into 2016. Each one of those years reshaped global weather in ways still referenced by scientists and disaster planners today. This 1997 to 98 event alone is estimated to have caused somewhere between $35 and $45 billion in damage worldwide, driven largely by catastrophic flooding across parts of the Americas and severe drought across the Western Pacific. This year's event isn't just on pace to join that exclusive list. Based on the current trajectory tracked against the daily development curves of those 3 previous events, this year is developing faster and earlier than any of them. That last point deserves real emphasis because it's the specific detail driving so much of the current concern among researchers. Climate scientists, comparing this year's Niño 3.4 warming curve directly against the historical record for 1997 and 2015, have found that this year is running measurably warmer than either of those previous super El Niño events at the exact same point in their development. Not 1997, which sat around 1.6 degrees Celsius above average at this same point on the calendar. Not 2015, which sat closer to 1.3 degrees. This year is outrunning both. And because El Niño events almost always continue strengthening through the fall before finally peaking sometime between November and January, that early head start suggests there's considerably more intensification still to come before this event reaches whatever ceiling it's actually going to hit. So why is nobody ready for this an honest, defensible statement rather than just an attention-grabbing exaggeration? Because of a specific, genuinely unprecedented detail that separates this event from every single super El Nino that came before it, and it has nothing to do with the ocean itself. It has to do with what this event is arriving into. Global average temperatures right now are already running more than 1.4 degrees Celsius above pre-industrial levels, a baseline that simply did not exist during 1982, during 1997, or during 2015. Every previous super El Nino in the modern record developed against a comparatively cooler global backdrop. This one is developing on top of the warmest baseline climate humanity has ever measured. Climate scientist Daniel Swain, who has specifically studied exactly this kind of compounding interaction, put the underlying reality about as directly as a research scientist typically allows themselves to in public commentary. We have never, in the entire era of modern climate measurement, experienced a strong or very strong El Nino arriving on top of a global baseline this warm. This isn't a repeat of a known pattern. It's a genuinely new combination of conditions that the modern climate system has simply never been tested against before. That distinction is the entire reason nobody is ready isn't hyperbole here. It's not that emergency planners, farmers, water managers, and coastal communities haven't dealt with El Nino before. They have, repeatedly, for decades. It's that the specific version of El Nino currently locking into place is stacking record ocean warmth on top of record atmospheric warmth. At the same time, for the first time anyone has ever measured, which means the historical playbooks built from 1997 and 2015 may genuinely underestimate what this particular event is capable of producing. It's worth walking through exactly how this pattern actually reshapes weather across such a wide stretch of the globe, because the mechanism is more direct and more physically intuitive than it might sound at first. Under ordinary conditions, steady trade winds blow from east to west across the tropical Pacific, piling warm surface water up against Asia and Australia, while cooler water wells up along the coast of South America. El Nino happens when those trade winds weaken, or in some cases reverse entirely, letting that built-up reservoir of warm water slosh back eastward across the Pacific, the same way tilting a bathtub sends water rushing toward the opposite end. Once that warm water spreads across the central and eastern Pacific, it fundamentally reorganizes where the atmosphere generates rising and sinking air, and that reorganization ripples outward, shifting the position of the jet streams that steer weather systems around the entire globe. That's the actual physical thread connecting a patch of unusually warm equatorial ocean water to flooding in California, drought in Indonesia, a suppressed hurricane season in the Atlantic, and a milder winter across the northern United States, all at once, thousands of miles apart from the ocean region actually driving the change. And this year, forecasters aren't just tracking the ocean signal, they're already watching it lock into the atmosphere itself, weeks ahead of when that typically happens in a normal El Nino year. Analysis of pressure patterns from late July into August shows a high pressure blocking pattern already emerging over the central United States and southern Canada, closely matching this historical signature seen during the buildup phase of previous super El Nino events, alongside low pressure zones developing over the west coast and over eastern Canada, extending into the eastern United States. That's a genuinely significant detail because it means this event isn't just theoretically capable of reshaping the coming fall and winter. It's already begun doing so in real, measurable atmospheric data, weeks before the seasonal outlooks most people actually check would normally start reflecting that influence. There's a technical wrinkle in how this event's strength is actually being measured that's worth understanding, because it changes how confidently you can compare this year against the past. For decades, El Niño's strength has been tracked using something called the Oceanic Niño Index, which simply measures how far Niño 3.4 sea surface temperatures sit above a fixed historical average. But because the entire ocean has already warmed significantly due to the broader climate trend, some researchers argue that comparing raw temperatures against an old fixed baseline overstates how unusual any given year's warmth actually looks, since the whole ocean is running warmer than it used to, regardless of El Niño specifically. To account for that, some forecasters now use a second measurement called the Relative Oceanic Niño Index, which instead measures how much warmer the Niño 3.4 region is compared to the rest of the tropical ocean at that same moment. Using the older raw index, this year's event is blowing every previous year on record out of the water for this point in the season. Using the newer, more conservative relative index, this year's event is running roughly neck and neck with 1997 for the strongest start on record. Either way you measure it, the conclusion holds: this is one of the 2 or 3 strongest starts to an El Niño event ever documented. And by the more aggressive measurement, it may already be standing entirely alone. It's also worth pausing on how this fast-developing signal has already scrambled some of the more traditional, longer-range seasonal forecasts published earlier this year. The Old Farmer's Almanac, using its own long-standing formula built around sunspot cycles and historical pattern analysis, projected a broadly hot summer across much of North America back in the spring, well before this El Niño signal had fully emerged in the data. That forecast wasn't wrong about the summer heat. But it illustrates a broader point worth sitting with. Even well-established, decades-old forecasting methods built without direct, real-time ocean monitoring can be caught off guard by a signal that develops as unusually fast as this one has, which is exactly why the agency is actually tracking Niño 3.4, sea surface temperatures in real time, rather than relying on longer cycle historical formulas alone, are the ones sounding the most updated, most urgent alarm as this fall approaches. Let's walk through, region by region, what forecasters are specifically projecting as this event continues building toward its peak, because the impacts aren't uniform. And understanding that variation is exactly the kind of specific, practical detail that separates genuine preparedness from vague, generalized anxiety. Across the southern tier of the United States, strong El Niño winters have a well-documented historical tendency to bring wetter than normal conditions, driven by a southward shift in the Pacific jet stream that funnels additional moisture into a region that often runs comparatively dry during non-El Niño years. That shift carries real, meaningful upside. Drought-stressed reservoirs across the southwest have historically seen genuine relief during strong El Niño winters, but it comes bundled with real flood risk too, particularly across California, where the 1997-98 event specifically produced the kind of atmospheric river storm sequences capable of triggering widespread, sometimes catastrophic flooding and landslides across the state. It's worth being honest that this signal isn't a guarantee, though. The 2015-16 Super El Niño, despite reaching genuinely historic strength out in the open Pacific, notably failed to deliver the wetter winter Southern California had specifically been bracing for, a reminder that even a record-strength event doesn't automatically translate into identical regional outcomes every single time it occurs. Meanwhile, the northern tier of the United States and much of Canada typically trend milder and drier during a strong El Niño winter, as the same jet stream shift pulling extra moisture south tends to simultaneously pull cold air and storm systems away from that region. The latest fall outlook specifically calls for warmer than average temperatures across the northern tier, alongside wetter than average conditions building across the southern plains, with that region specifically expected to flip from an above average temperature pattern into a below average one as the season transitions from September into October and November, a genuinely notable shift for a region that spent much of this summer under persistent, punishing heat. Out across the Pacific, Indonesia, and northern Australia have historically faced severe drought conditions during previous Super El Niño years, a serious concern for agricultural regions home to hundreds of millions of people. While portions of East Africa have historically seen the opposite problem, unusually heavy short rains flooding, a well-documented pattern specifically tied to both the 1997-98 and 2015-16 events, current forecast data adds another layer to that Eastern Hemisphere picture, showing positive Indian Ocean dipole conditions becoming dominant through the fall, a related oceanic pattern that tends to amplify exactly this kind of east versus west rainfall imbalance across the Indian Ocean basin, intensifying both the drought risk in some regions and the flood risk in others simultaneously. And then there's the Atlantic hurricane season, which connects directly back to something that's already been quietly unfolding throughout this entire summer, whether or not most people following the news have specifically linked it to this larger pattern. A strong El Niño reliably increases wind shear across the tropical Atlantic, winds at different altitudes blowing in different directions or at markedly different speeds, strongly enough to tear apart developing tropical storms before they have a chance to organize and strengthen. That's not a coincidental, unrelated detail sitting alongside this story. It's a direct, well-documented mechanical relationship, and it's the specific reason this year's Atlantic hurricane season has been running so unusually quiet, with forecasters at outlets specifically tracking this connection, describing the rapidly growing El Niño as likely to force one of the slowest hurricane seasons in years. The same oceanic pattern currently pushing potentially record-breaking rainfall extremes and drought risk across other parts of the globe is, at the very same time, actively suppressing an entirely different hazard on the other side of the world. A genuinely striking illustration of just how far-reaching and interconnected El Niño's global influence actually is. There's a specific atmospheric structure driving this fall and winter outlook that forecasters keep returning to. And it's worth explaining plainly because it's the actual mechanism behind why the coming season is expected to feel so unusually amplified rather than just generically active. Meteorologists are describing the emerging setup as a split flow pattern. Essentially, the jet stream dividing into two separate branches as it crosses North America, one diving south to deliver moisture and storminess across the southern tier of the country, The other riding further north across Canada, with a sharper than usual contrast between the two. That split isn't a subtle technical detail, it's the specific structural signature researchers have identified in the pressure data from each of the last 4 Super El Nino events. And it's the reason regional outcomes this fall and winter are expected to diverge so sharply from one part of the country to another, rather than simply nudging the whole continent slightly warmer or slightly wetter in some uniform way. And the influence isn't stopping at North America's borders either. Forecasters tracking this same pattern have specifically flagged the pressure blocking signature beginning to extend its reach into Europe as well, a continent that, in earlier stages of this event's development, had shown no clear El Niño-linked signal at all. There's also a planet-scale consequence sitting underneath all of this regional detail, and it's arguably the single most direct reason NOAA's own forecasters have started reaching for words like historic in official communications, language that federal agencies typically avoid specifically because it invites exactly this kind of high-stakes framing. Even without any additional El Niño influence at all, 2026 was already tracking toward ranking among the hottest years ever recorded, based on the underlying global warming trend alone. El Niño events reliably add an extra boost of warmth to global average temperatures on top of whatever the background climate trend is already doing, because all of that additional ocean heat being released into the atmosphere doesn't stay contained to regional weather patterns. It measurably raises the global thermometer for the year, or in some cases the 2 years, immediately following the event's peak. Multiple climate researchers have specifically pointed to the realistic possibility that a super El Niño of this magnitude, arriving on top of an already warming planet, could push 2026 or potentially 2027 as the delayed thermal effects continue working through the system into the record books as the hottest year ever measured, surpassing the previous record set in 2024. So what does nobody is ready actually look like in practice once you move past the raw meteorology and into the specific practical gap this event is exposing? It shows up in a handful of concrete ways worth naming directly. Water infrastructure across the Southwest, built and permitted around decades of drought-era assumptions, may need to rapidly shift toward flood management posture if the wetter winter signal materializes as strongly as current models suggest, and that kind of infrastructure pivot doesn't happen on a timescale of weeks. Reservoir release schedules, flood control planning, and levee maintenance all typically operate on much longer institutional timelines than a single fast-developing seasonal forecast. Agricultural planning across the southern plains, a region that spent much of this year locked in persistent heat and dryness, now faces a genuinely disorienting whiplash scenario, with forecasters projecting a flip toward wetter, cooler conditions, arriving in the exact window when farmers would ordinarily be finalizing fall planting and harvest decisions based on the opposite assumption. And across the Atlantic hurricane basin, an unusually quiet season so far has, in some places, quietly eroded the kind of active, front-of-mind storm preparedness that a more typical, more visibly active season tends to reinforce naturally. A genuine risk, given that even a historically suppressed hurricane season doesn't guarantee zero storms, only fewer of them, and a single storm finding a gap in otherwise hostile atmospheric conditions can still produce a serious, damaging landfall regardless of how quiet the overall season has been. It's worth being genuinely careful and honest here about where real confidence in this forecast actually ends, because overstating certainty erodes trust just as thoroughly as understating a real risk does. This is not a guarantee of a specific, predetermined outcome in any single location. Regional rainfall and temperature projections tied to any El Niño event, even one with as much model agreement behind it as this one currently has, still carry genuine uncertainty this far in advance. The 2015-16 event stands as direct, well-documented proof that even a record-strength El Niño in the open ocean can still fail to deliver one of its most historically reliable regional signals. What can be said with real, evidence-based confidence is narrower, but still genuinely significant. The underlying oceanic and atmospheric pattern currently building across the Pacific is developing faster and trending toward a higher potential peak than any El Niño event in the modern historical record, including the 2 previous events widely regarded as the strongest ever measured. And it's doing so on top of a global climate baseline warmer than during any of those previous events, a combination multiple climate scientists have specifically and publicly described as genuinely unprecedented. There's a broader, more human way to understand why so few people have fully registered the scale of what's building here, and it has less to do with the quality of the forecasting and more to do with how attention naturally works during a slow-building story like this one. A hurricane approaching landfall in 72 hours generates an immediate, visceral, easily communicated sense of urgency. A clear countdown, a clear map, a clear moment when the danger arrives. A gradually strengthening oceanic pattern, built up over months, described using technical terms like Niño 3.4 anomaly and effective shear, measured in fractions of a degree Celsius, simply doesn't generate that same visceral urgency, even when the underlying stakes, measured in dollars of potential damage and millions of people across multiple continents affected, are considerably larger than any single storm. That's part of why a story like this one can sit in plain view, confirmed by multiple independent government and academic forecasting agencies, covered accurately in specialist meteorological outlets, and still remain largely outside the everyday awareness of the general public until its effects actually start showing up as flooded streets, disrupted harvests, or an unusually mild wet winter that catches people off guard specifically because they never saw the underlying signal building months in advance. That's really the practical, useful takeaway sitting underneath this entire story. And it's worth ending on directly rather than burying it under one more layer of technical detail. If you live anywhere within the regions historically sensitive to El Niño's influence, the flood-prone corridors of California and the broader Southwest, drought-vulnerable agricultural regions across the southern plains, now facing a genuine seasonal whiplash, coastal communities along the Gulf Coast and Southeast that could see an active, wetter pattern build through the fall and winter, or simply anywhere planning around the assumption that this coming winter will look roughly like an average one. This is a genuinely useful, evidence-based moment to actually engage with your region's specific El Niño outlook, rather than letting this story blend into the general background noise of routine seasonal forecasting. Checking your area's historical El Niño rainfall or drought signal, following your local weather service's updated seasonal outlooks as this event continues to intensify toward its projected peak, and treating this fall and winter as a season worth actively planning around rather than passively waiting to react to, are all genuinely practical steps grounded directly in what the current data is already showing, months before the coldest, wettest, or driest parts of the pattern actually arrive. Because that's ultimately the real, honest shape of this story, stripped of exaggeration but without softening what the data genuinely supports. A weather pattern that scientists have studied and tracked for well over a century just sent a signal strong enough and moving fast enough that the researchers, whose entire careers are built around interpreting that exact signal, have started reaching for words like historic and unprecedented, not as dramatic flourishes, but as the most technically accurate language currently available to describe what's actually showing up in the data. Whether the coming months ultimately confirm the most extreme end of these forecasts or land somewhere more moderate, the way previous events have occasionally done, the underlying signal driving this entire story, a record pace, a record potential peak, arriving on the warmest global baseline ever measured, is one worth genuinely understanding now, while there's still time to actually prepare for it, rather than months from now, when it's simply the weather everyone is already living through.